Hello. Yay. Fine. Okay, so welcome back to the stream. Today we are going to look at another design pattern called as the strategy design pattern. Okay, so let's start by introducing myself for those of you who don't know me. I'm Shiben. I'm a lead software engineer with around 9+ years of experience in the software industry. I am a full stack developer with Java, React.js, and CI/CD stuff like Docker. I have experience in all of them. So that's a short intro about me. And we have been doing a lot of courses like this on YouTube. If you go to the Fastorial channel, you will see that there are past courses already. So we completed a Java multi-threading course, and then we did a Java Streams API course. We also did a Spring Boot plus React.js full stack project course, which we deployed on the cloud as well. And now we are working on this design patterns course. Okay, so we already did one video in this, which was the observer design pattern, and this is the second one. Okay, so those of you who are watching in the vertical video, you can switch to the horizontal video by clicking on the link in the description. Those of you who are watching the horizontal video, you can see the notepad which says what is the plan, right? So we completed one so far, which is the observer design pattern. There are many more which we'll be doing in the upcoming streams. Okay, so one new thing today is that I designed a web page for the channel. It's at fastorial.dev. It's there in this video's description as well. You can go there and check out. So we actually created some channels where students can join and ask doubts, or if you have any questions about careers or anything, any doubts in Java, or if you're stuck somewhere, you can go to any of these communities, either Discord or WhatsApp, or there'll be a Telegram also. If you guys want Telegram, I'll share that link as well. You can just go there and connect. Okay, so you can connect with me as well. I have added my LinkedIn profile here. You can DM me. I'll help you with referrals, or if you have any doubts with that. Okay, and these are the past YouTube playlists. I added that also here in this web page. Fine. So if you get there is a place where I added upcoming courses also. We are planning. So this design patterns is in progress, which we are doing now. There is also a planned Java interview preparation and system design masterclass also, which we will do later. Okay. So the system design will be having LLD and HLD also. That's the plan. Okay, so that was it. Let's start today's class. Okay, so first question we will see is, what is the problem that we are solving? Okay, so whenever there is an operation that can be done in many different ways. Okay, so there could be many operations in a program where you can do a same thing in many different ways. Okay, we'll see examples below. Examples are there below. I'll say you, and you want to switch between these ways dynamically, right, without using big if else or switch statements. So if you do if else, you can switch, but then we do not want to do that, because that becomes tightly coupling. So you shouldn't tightly couple your program anywhere. You should have extensibility of your program. So whenever you write if else, not normal if else statements, like big if else statements to switch strategies, right, that is when the issue is. So I'll show what kind of problems they are. Okay, so examples: in Google Maps, you can choose either to walk or bike, go by bike or go by car or metro. You can choose these different strategies. If you're doing an Amazon payment, you can switch between doing a card payment or a UPI payment or wallet payment, the different kinds of payment. If you say notifications, you can do email or SMS, WhatsApp. Or if you do sorting algorithms, which is more technical, you can do merge sort, quick sort, bubble sort. Different sorting algorithms are there, right? And you might reach a point where you want to pick one of these strategies dynamically, right? And if you are going to write if else, let's say Google Maps has this 4 sections to decide an algorithm for walking versus bike versus car versus metro. Okay, now imagine if in one class you wrote all of these 4 items with if else block, right? That will look very nasty. And if tomorrow, let's say, you have to add a strategy or flight path, that is going to be a big headache, right? Because you have to mess up with the existing class logic. So that is where the strategy pattern comes in, where the how part is decided. Okay, so I'll go to the definition of strategy pattern. So a way to swap, 1 second, right? So a way to swap how something is done. Okay, so this how part is what is important for us. Okay, how something is done without changing the existing code that uses it. Okay, so if there is an existing code which is using a payment strategy, for example, so I shouldn't touch that existing client code, but I should be able to add a new payment strategy, right? So that is what it is called. So this how something is done is called as strategy. Fine, so that is what we are going to discuss today. Now there are some key terms in strategy pattern. So one is the client, the other one is the context, the last one is the strategy itself. Okay, so if you remember, in the last class we discussed observer pattern, right? In observer pattern, the two key terms were publisher and subscriber, right? So similarly in here the key terms are client, context and strategy. So we have to make sure remember this throughout the application, then only we can design it properly. Okay, so what is the responsibility of each person? So client is the one who picks the strategy. Okay, the client, for example, I am going to say that I am going to pay via UPI, or I am going to pay via card, or let's say if you choose Google Maps, I'm going to say that I'm going to take a bus or take a car, things like that, right? So I am the one who picks the strategy, so that is the client. Then you have context. Context is one that stores the strategy. Okay, so we'll look deeper as to why the storing of strategy is needed, but that is the one who stores the strategy. Okay, so when our client picks the strategy, it's stored within the context. And the last item is the strategy, which says how to do something. So how to draw a map for walking, or how to figure out a route for taking a car, right? So those kind of strategies are designed by the strategy part of the whole architecture. Okay, so that was all about the definitions and things. Now let's switch to the problem statement. Okay, so we are today going to design an Amazon payment processing system, okay, which actually does the following. Okay, design and implement a simple payment processing system that, first point is, allows user to make payments using different payment methods, example card, UPI and net bank. Okay, so we are going to choose 3 payment strategies: card, UPI and net banking. Okay, and the second thing is, select the appropriate payment algorithm at runtime based on user input. Okay, so I, as a user, I'm going to say I want to do card payment. Okay, and the strategies should be picked dynamically, right? And the third one is, processes the payment using the chosen strategy, right? So whatever strategy, if I choose card pay strategy, then it should use that strategy. And the fourth one is, allows easy addition of new payment methods without changing existing checkout logic. Okay, so checkout logic is what will trigger the payment, right? So we shouldn't touch or disturb the checkout logic, but still a new payment strategy should be added. Okay, so that's the point. Now if I see the flow diagram here, this is what will happen. So from the cart system, right? So when you have a cart with objects in it, hey Divya, hi. So let's say you have a cart system, a cart service where you have items and you click checkout and then it goes to the payment service, right? So the payment service says, allows you to choose, do you want credit card or debit card or net banking or ePay, right? Things like that. So that is what the flow diagram here is. So the strategies are these, like credit card, debit card and all, and the client is the card service here. Okay, the client is actually the person who checks out, actually, essentially. Okay, fine. So with that, the flow diagram is also done. Now let's look at the example input output. So input is, as we saw in the observer pattern, input comes from the system in, the client types in the input and the output gets printed onto the system out, right? It gets printed to the console. Now this is the example console interaction that I want to have. Okay, so someone can choose to pay via card and then give the card number, right? The card's 16-digit number, and then say the amount 450 rupees, and then it says payment of 450 processed using card ending in the XYZ number. So similarly, someone can say pay using UPI and give the UPI ID and the amount, and it says a message saying that it was processed using UPI. And then the other one is pay using net banking strategy, and say the HDFC, I mean like the account number and IFSC, right? That's what is needed for net banking. And then say the amount, and then you process that payment as well. Okay, so this is all we taken as input, and that's the expected output. Okay, so now let's look at the class diagrams. Okay, so the payment service is the one that we're designing. Okay, so this is going to be the first key term which we saw, that is a client. Then we have a payment processor, which is the context, and the last thing is the strategy, which is the actual strategy itself. Okay, so let's go one by one. So the payment processor or the context, sorry, where's the client? Yeah, so the payment service, which is the client, right? He stores the processor, which is the context. So inside the payment service, you have the processor to which you say this is the strategy I want. Okay, so this is the guy who stores the processor itself, and inside the processor you have the actual strategy, right? If I go inside here, right, so you have the payment strategy inside the payment processor, and then it has one method, just one single method saying process payment, and you give the string amount. Now you might think, where is the metadata stored? For example, the metadata of the card number or the UPI ID, where is that stored? That comes inside the implementation only. Okay, we store that in the implementation of the payment processor. Fine. And there is one more method saying process payment, which got extended from up, right? Implemented from, overridden from the interface itself. And then we have the payment strategy, right? Here what we have? Here we have the process payment function, which takes in the metadata and the amount. Okay, so we take those two things and process the payment accordingly. So here we have three strategies. One is called the card payment strategy, UPI payment strategy, and net banking payment strategy. Fine. Okay, so that is that. Now let's start coding. Okay, so we'll start from bottom to top, because the dependencies are coming from up to down, right? So payment service needs processor, processor needs payment strategy, right? So first I'll write the strategy, so that when I write the payment processor, you will already have that object. Okay, so always remember three things. If you have the clarity of these three things, the client, context, and strategy, you will know what to put where and easily design this. Okay, fine. So let's discuss one more problem. Let's say you are making an Amazon map service. So in that case, the client will be again you, the one who is choosing the strategy, and you will have a route processor, or like route design processor, which designs the route for you. Okay, and in the route processor, you just say the X and Y, like the start target and the end target, right? And that will be the interface you have here. And in the strategy, the route strategy, you say pick either car route strategy or bike route strategy, things like that, right? And in the respective strategy implementations, it will be written for going from X to Y, what is the strategy to be based on the strategy, how do I go? So the how part is in the strategy, right? So it decides how to do the routing and shows you the map, with the XY, with the lines and all saying how to go there. Okay, fine. So let's start coding. I will go back to IDE, and I already have this, design patterns GitHub repo. It's there in the video's description. You can go there and pick the old one, the observer pattern. Now I'll create a new one for strategy pattern. Okay, so I'll start with the strategy interface. Okay, interface, and I'll put it inside. Oh, the package name didn't come. So a new interface. Okay, I'll put it inside strategy, and I'll call it I payment strategy. Okay, so from last stream onwards, we are doing this convention where if it's an interface, we start with the letter I. Okay, it's Java doesn't care. It is just for our ease of use. Okay, so now in the payment strategy, what all are there? There is only one function called process payment of metadata and amount. Okay, so metadata is the actual payments metadata and the amount. So let me create another interface for that to store the metadata. New interface I payment metadata. Okay, and I'll put it inside .meta. Okay, I'll put it inside a package called strategy.meta, and I'll finish this. Okay, now let's go back to payment strategy, and we can write our function here. So public void process payment, and it will take the metadata, payment metadata, right? Meta, and it will take the amount, double amount. Okay, fine. So with that, our payment strategy is done. So we have just one function here saying process payment by taking the metadata and the amount. Okay, let's go up one step. So I'll come to the implementations. Let's go one step up. And in strategic payment processor, oh, before that there is iPayment processor, right? The interface for the context. So let me create this next. Okay, so I'll do one thing. I will put this into respective packages. Okay, so this is the strategy itself, right? So let this be in the strategy package itself. I'll create one for the context dot context, and I'll call this iPayment processor. Okay, that's the context. And inside iPayment processor, there is just one function called process payment, and it takes only the double value. Okay, double amount. Okay, so that is done. I am actually returning string. Okay, let's return string itself instead of void. So the string will be the actual message that we have to display on the console. Okay, so I'll return string here as well. So if you see here as well, I'm returning string. So whatever is after this colon is the return type of this function. Okay, okay. So the payment processor interface is also done. Okay, now let's write the Amazon payment service. So if I go here, and that will be a concrete class, right? Because that is where you are processing the payment. So that will be the client, and it will be Amazon payment service. Okay, so in here we have to have the main function which we will invoke, and that will actually invoke the payment processor. Fine. So now to invoke the payment processor, we should actually have a payment processor, right? So let's go back and write that. So I will create a strategic payment processor, which is the context now. So new class, okay, strategic payment processor, which means like it uses a strategy to process the payment. Fine. And in here I'll use our payment processor. So I'm actually implementing a payment processor. Hey, what happened? Okay, so I'm implementing a payment processor, and it gave us this. Where is it? Yeah, so it gave us this process payment function, which we have to now implement. Okay, so for process payment function, we will first of all have a strategy. Okay, so iPayment. So if you remember, context is the one that stores the strategy. So inside context, I'll have strategy. I'll go back to the diagram and show if you want. So payment strategy is the iPayment strategy. Fine. So payment, or I'll just say strategy. Okay, strategy, and there should be the metadata also. Okay, so client gives the payment metadata also to the context only. So this guy is actually the main processor guy. He needs to know everything. It's like, remember, think of him like a cashier. Okay, so to the cashier you say this is the card number, and this you give the amount also, right? So you give both of them. So let's say to the cashier, instead of giving the card, you are saying I'm going to do UPI payment. Let's say you are at a store and you're saying I'll do UPI payment, right? So now he become the context. He knows, okay, you're going to do UPI payment, so I have to generate a QR code to you and take the amount. I mean, say how much ever the amount is, okay? So that he takes the thing. So this is the guy who stores both of that. So I pay here. Oh, I didn't create an interface for this yet, right? Did I? Oh, it's there here. So I payment metadata. Payment metadata. Fine. So we will make them immutable. So how to make something immutable? Mark it as final and inject it in the constructor, okay? So go to source menu. In Eclipse there is source menu, and then go to generate constructor using fields. Select all the fields and click on generate, okay? Fine. So with that is done. Now all we have to do is just to return strategy dot process payment, okay, and pass in the metadata and the amount. That's it, okay? So why immutable? So Divya is asking why immutable. It's because so whenever you build any kind of oops application, right, try to keep things as immutable as possible. I mean, make sure that it never changes. So why that is it's a good design practice. When something is immutable, it becomes thread safe, and it means that it is final, it is solid. So if I have a strategic payment processor and I feed in the strategy and meta, right, I can never change these values after that. So whenever I use that object in the future, an instance of this class in the future, I know that these two values are never going to change. The strategy and meta is not going to change, right? Which means nobody can set these values. You cannot do dot set strategy or dot set meta later on. So you can pass around this object anywhere within the whole application and it will always stay the same, right? Which makes it a solid, it's like locking the values, right? So if at all you can lock a value, you always try to make it final. If it changes dynamically, right? So you know that meta is not going to change. Like let's say you gave your UPI ID, it's never going to change in the future, right? Throughout the processing of the payment, it's going to stay the same. So you have to make sure that that is finalized, like immutable, okay? So that's a short answer to that. I mean, that is one of the reasons. I think there are like 3 or 4 more reasons, but always try to make your class variables immutable, okay? Samyadeep Saha says great explanation. Thank you. Okay, so moving on. Where was I? Now we go to the payment service, or actually, yeah, so we have fully built this, and I wanted to say one thing. So you see the beauty of this. Let's say you add 10 more strategies now, okay? You are this context, right? It never changes. The context is always going to be the same. The client is going to say you the strategy. You are going to forward that request to the strategy object, right? So you see here, whether you choose card strategy or UPay strategy or whatever it is, it's simply going to do strategy.process payment and pass on the metadata and the amount. So that is what we were seeing in the definition as well, saying, where is it? Right? So how something is done, a way to swap how something is done without changing the code that uses it, right? And it says here also, you have to switch between the ways dynamically without using big if else or switch statements everywhere. So that is the whole concept of the strategy patterns, okay? So now let's implement the strategies. I will write this card payment, UPay payment, and banking. Where is card payment? New class. Okay, I'll implement this payment strategy, and card payment strategy. Okay, didn't add it. Payment strategy. Okay, so I'll implement that, and this will just return a string which was shown in our input, sample input output. Where is it? Here, right? So when you have a card payment, it is supposed to say this payment of 450 processed using. So I'll just return this string, hard code it now, and we have to get this 450 and this card number from the metadata. Okay, so for this I also need So if you do meta.get now, so if I do meta dot, there is no card number here, right? Because that's a dummy interface. It doesn't have any data inside. See, there is no get card number or anything like that. So what I'll do is, I'll create one more implementation for the metadata. Okay. So if I go back here, new, I'll create a record object. So I hope you guys know what record is. Oh, so it's yeah, I have been facing this issue in my IDE. So it says it's not Java 16 compliant. So if you guys also face the same problem, right click on a project, go to build path option, go to configure build path, and go to this Java compiler, untick this use compliance from execution environment 1.8. So it's in 1.8 compliance. That's why it's showing error. I think records were introduced in Java 17. So I'll go to JDK 17. You should set the compliance level to JDK 17 and click apply. Okay. And click yes. And now you should be able to create a record. Oh, record was created in 17. I didn't know that. Why did it take so long for them? It looks like a very basic thing. Okay. So card payment meta, and I'll add iPayment metadata. Okay. Fine. So we created it, and for a card, what all are needed? The card number, okay, number, the CVV. So I'll just store everything as a string for now. I'm not strictly looking at numbers and all. I'll just take everything as numerical, textual inputs, okay, and expiry date. These are the three things that we need, right? Date. Fine. So what happened? Oops, I wrote it like a class. So you're supposed to write it here, comma. Okay, so this is how you define a record. You have to pass the variables as arguments into this parenthesis. Okay, not like how you write it in class inside the curly braces. Fine. Records came in Java 14. Oh, okay, cool. Okay, so let me come back here. So in here, this is going to accept a card payment metadata, right? So I'll pass this here and it fails. Okay, yeah, it is going to fail because this interface, right? It is saying use iPayment metadata, but then I cannot take its child. So how to solve this? This is kind of not related to the problem that we are solving now, but then we have to use generics here. Okay, so I'll say how to do that. If I go to this, right? So payment strategy of P meta. Okay, so I have to pass this here, and it says extends iPayments meta. So I'll explain what is happening. Let me write this. Okay, so we are actually going to make this payment strategy into a generic type with saying that you can pass any type of payment metadata into it. Okay, so whenever someone passes a, let's say, card payment, this metadata becomes a card payment. And similarly, right, UPI payment, this metadata becomes a UPI payment metadata. Okay, so once I do this, now I can go to my payment strategy, card payment strategy, and say I am going to, have a metadata of type card payment, right? Card payment metadata. Okay, and then I can pass this value here. Okay, so this is how you work with generic types. Okay, so whatever T or like whatever generic type I passed here, T meta, you have to use it in the process payment function also. So when I go to card payment strategy, I pass it down here. Okay, now I can simply do card, where is it? Card ending, and then I can pass the meta dot card number. Okay, I'm actually printing the whole number. You have to actually print just the 4 digits. That's the actual question. Fine, that's not very important. Anyway, so now here I'll print the amount. Okay, fine. So we completed just card payment, and strategic payment is showing a warning here, because we now made the strategy into a generic type. So we have to make this processor also generic type, otherwise it shows a warning. This is not very important to fix it also. If it just shows a warning. If you really want to fix it, let's do that as well. Okay, let's do that. So meta, and whatever is this metadata will be here, and this strategy will take that metadata. Oops. And this dot strategy takes in, oh, actually I don't need to pass it. I have to pass it, right? Yeah. Okay. And what is happening here? Strategy dot pass this meta. This payment metadata. This is correct, right? It should be meta. What does it say? The method process payment of I payment is undefined for type I meta. T meta. Okay. Hey, this should be here. The strategy is still the strategy only. Strategy of okay, didn't I make this? Okay, we'll come back to this. I'll undo this. We'll look at this in the end. Okay, we'll just keep the warnings as it is. Okay, we'll come back to it. This is not going to cause any errors. It's just a warning. We will make it strictly type safe later. Okay, so now card payment is done. Card payment strategy is done. Now let's just try to call just a card payment, okay, and see what is happening. So if I close all this, I close this, close this, close this. Okay, so first thing I will need a context, right? So I payment processor is our context. Processor equals new strategic processor, right? Strategic payment processor, and that takes in two parameters, which is the strategy and the metadata. Okay, so let me add that. So first I need I payment strategy of card payment, right? Card payment meta equals new card payment strategy here. Okay, card strat. Okay, so first argument is done. Now what is the other argument? The other argument is the metadata itself. So metadata meta equals new card payment. Okay, and it takes in the card number, CVV, and expiry date. Okay, so I'll give those values. So what is the card number that they gave here? This one, right? Okay, card number, CVV, I'll just give some random number, and expiry date 12/2025. Okay, some random value, and I'll give the metadata also here. Okay, and now we call processor dot process payment, and we give in the value $450, right, or rupees. Okay, now this is supposed to give us a string, which is like the payment result, and we will print that here. Okay, now let me run this, run as Java, and you see it says payment of 450 processed using card ending and then the card number. Okay, so with this we completed one strategy so far. Okay, now let's say You want to add new strategy. So the question it says here, right? Allows easy addition of new payment methods without changing existing checkout logic, right? So this checkout logic is what we have in the Amazon payment processor. Okay. Now, if I have to add a new strategy, let's say I have to add a UPI payment strategy, what else should I change, right? So I have to first of all, so one thing I made mistake. Let me just quickly fix it. This should go to strategy. It's not metadata related, right? Let me move it. Okay, fine. So if you see here in my class list, I have to first of all have a new strategy. Where is strategy? Here. So I have a card payment strategy. Similarly, I have to have a UPI payment strategy. Okay, that is one thing. Next, what should I have? I need to store it the metadata of UPI payment somewhere, right? So I'll have a UPI payment metadata record, right? It's a record for that. That's it. Only these two I need to add. Now I need not touch the processor. I need not touch the I need not touch the processor essentially. That's it. So the context never changes. Only the client I have to say, because client has to anyway pick it, right? Anyway, he has to pick like I need to do a UPI payment. Someone has to say to it. So only the client, we add some extra line of code saying do a UPI payment, right? The processor never knows what change happened outside. Fine. So let me do that. Okay. So I'll create a new metadata. I'll just copy paste the card payment meta and call it UPI payment meta. Okay. And UPI payment, you just have one value, which is the UPI payment. I mean UPI ID. UPI ID. Okay. I'll remove everything else. Save it. And I need to have a strategy for UPI. I'll copy paste the card payment strategy and call it UPI payment strategy. Okay. Click OK. And inside UPI payment strategy, what are we going to do? First thing is UPI payment strategy is a type of, it takes the metadata of type UPI payment meta, right? UPI payment meta, and here also pass in UPI payment meta, and the message will also change. So message, where is the message? Right, it says this payment of 120 processed using UPI ID something something. So I'll remove this existing message, and it's supposed to say amount processed using UPI ID, and the UPI ID will come here like this, meta dot UPI ID. Okay, so you got everything that you want. Fine. So you finish the whole strategy. The strategy of UPI payment is done. Now you go back to, oh, that's it. You have to just change these two. Now you go back to the client. So Amazon Payment Service is the client here. Okay. So let me just write it here. So this is the client. The payment service. Where is the payment service? Oh, sorry. Oh yeah. The client payment processor. This is the context, and the strategy is the actual strategy. Okay. So if you guys are revising, whenever you revise, just remember that there are these three entities and you have to work around these three. Okay. So you should also know what is stored where. That is one more important thing that I showed in the flowchart, right? Okay. So I'll copy paste the same thing for card, and I'll just make changes for UPI now. UPI strat is new UPI payment strategy. Okay, and it takes in UPI metadata. Okay, and UPI meta is going to be this, and it's the same processor, so I'll call it UPI processor. Okay, and I need to generate a new UPI payment meta. UPI meta equals new UPI meta, and I will give the UPI ID. What is the UPI ID? This one. Okay, and remove this card payment meta. Okay, and here I gave this already. That's it. So to the processor I gave the UPI strategy. I should give the UPI strategy, and I gave the UPI metadata and the payment result. So this will be UPI payment result. UPI payment result. Okay, and I'll paste it here. And I'm not calling this UPI processor. UPI processor dot process payment. Okay, fine. So let's run this now. And you see we got two items. One is payment of 450 using card. Another one is payment of 450 using UPI ID. Let me make it like 200 or something so that you see a difference. Okay, so we got the two different payments. Now if you have to add one more also, the same story again, right? For net banking also it's the same story. So I don't know if we have to do that now. We'll try to fix that issue where I told about type safety, right? So if you see now, even when I was making code change, something happened. So let's say I took the, where is it? Card payment meta, right? Okay, let me call this card meta. Okay, if I take this and pass it here in the UPI payment processor, what will happen? It will not show any error. You see, there are no red symbols anywhere, right? Nothing is erroring. But now if I run the code, right? So compile time, nothing happened. If I run the code, you see it failed. So this is the problem. So it says class cast exception, class card payment metadata cannot be converted into UPI payment metadata, right? So that is the issue. So that is what we were trying to solve there. You should have everything strictly typed. So if you have that thing, then it wouldn't even allow you to pass a card metadata into UPI metadata. Okay, so for that we have to go here and change something. So I'm kind of messed up there. Let me see how to fix it. So to the processor you have to say meta type. Okay, that is done. Now the metadata type will go here also. Why is this failing? So here, okay, so I saw the error now. So it says T meta is not valid substitute for bounded parameter T meta extends I payment metadata, right? So what happened is in payment strategy, I mentioned that this should be bounded, as in it should be a type of metadata. Okay, but in my processor I didn't do that, so I have to specifically say that there also. Okay, so I'll say that here. Okay, now that error is gone. Now next thing is the metadata itself is what is coming in here, right? It's not iPayment metadata anymore. So that is this. So we made that also generic, and here also it's the same thing. Okay, and here in the strategy also it's the same thing. It's the strategy of this. Okay, and with that all errors are done. Okay, so now let me go back here. Okay, and it, you see now the yellow underlines came here. It went from the processor and it came to the client, right? So here what we have to do is we have to do this type, diamond operator. I think as soon as you do this you'll get error, right? See, immediately it got error. So now you fix the error in compilation itself. So this is why the generics, you should never ignore the yellow underlines, right? So that you write proper code. So now you know that by mistake you passed card metadata inside a UPI processor. Okay, so if I change this with UPI metadata, the error will go away. See, gone. Okay, so let me run this again and we got that answer. Okay, so that was all the demonstration of strategy pattern. I will just do net banking also. So if you guys are interested, you can stay, otherwise you can leave. Okay, because it's just copy pasting the same what is it, UPI payment stuff or like card payment stuff, and then calling it again, right? Because it's just STD out. So if there was actual making calls to UPI ID or something, then we would see different implementations, but we are simply printing out something, right? So it's going to be the same thing. Okay, So let me quickly do that. I'll do that and commit it to GitHub. Okay. So first thing I want is net banking metadata. So I'll copy paste UPI meta and call it net banking payment metadata. Okay. Inside net banking payment. So I'll have the account number and IFSC code, right? Those are the things needed for net banking. And I'll create one more strategy for net banking and call it net banking payment strategy. Okay, and inside that the metadata coming inside will be a net banking payment metadata. Okay, and this will also be a net banking payment metadata. And what will be the message? It will say this message. Okay, and this will be the amount processed using net banking account, and it's supposed to say meta dot account number. Okay, it's fine. So with that, the strategy is also done. So it just took like 2 minutes because we have it in strategic way. If we were to disturb the payment processor, that would be a big headache. Okay, now we build this. I'll just write it here. So this was card payment starts. Okay, and card payment ends here. Here UPI payment starts and it ends here. Okay, and here net banking payment starts, and I'll copy this thing, and this will be net bank meta. Okay, and that is going to be a type of net banking meta, and that takes in 2 values. One is the account number, something that looks like this, and then the IFSC code, which looks like HDFC 000 something number. Okay, and the strategy also takes this meta, and this is going to be net bank strategy. It's going to be net banking strategy. Okay, and the processor is going to be a net bank processor, and the result also is going to be a net bank payment result. Okay, and let's say I paid 50,000 via net banking. Okay, all good. Let's print and see. Run the code. Yeah, so payment of 50,000 processed using net banking account, and you print the net banking account number. Okay, so that's it for strategy pattern. I think I covered everything that I had in mind. I'll just commit this code and close the stream. Okay, so if you guys have any questions, if you want me to go through any of the section once again or anything like that, just drop it in the comment. I will explain it. Okay, so okay, so if you go here, right, we have observer and strategy, 2 different codes. Okay, fine then. We finished our stream. It's been 52 minutes only. So short pattern, but a very important pattern, because this is going to keep reoccurring in our future design patterns. Okay, so make sure you understand it properly. Remember this cheat code. Okay, that's the most important thing. Where is it? So the key terms are client, context, strategy. Okay, keep saying it even when you're sleeping today. Remember it. Fine. Thank you all. Thank you for joining the stream. See you guys in the next one. Bye. Have a great day.